Hey guys, and welcome to learning about the distance formula. Now, again, this is another really useful equation that is seen a lot on the ACT. A lot of different problems ask you to utilize the distance formula, and sometimes this coupled with the midpoint formula, which the previous video shows. So, with the distance formula, you will generally be given 2 points and you'll be asked to find the distance. That's where it gets its name. So you have an XY coordinate plane and you'd have a point here and a point here. This is a X1, Y1, this is a Y or X2 and Y2. You'll be told to find the distance of this line segment. Well, the basic kind of cookie cutter equation for this, what's called distance D, is the square root of, you would have x2 minus x1, and that quantity squared, plus, another parentheses, y2 minus y1 quantity squared. And then you take the square root of that. Now, why do you think that these are both squared? Well, I'll give you a hint. You can't take the square root of a negative, and distance is always positive. So that explains these. Now, let's do an example of these types of problems. Okay, let's say we're given 2 points. Let's say 3, 10, and 13, negative 11. We're told to find the distance between these 2 points. Okay? Actually, I don't like this. Let's go 3, negative 6. There we go. I like that a little bit better. So, distance. We've got the square root of, we've got x1, y1, x2, y2. So it's x2 minus x1, so 13 minus 3 squared, plus y2 minus y1, so we've got negative 11, and then minus y1. Well, minus negative 6 becomes plus 6. So D equals the square root. 13 minus 3 is 10, and 10 squared gives me 100, plus negative 11 plus 6 would give us negative 5. But since we're squaring it, it becomes positive 25. So D equals the square root of 125. Well, we could rewrite that as the square root of 25 times 5. We know the square root of 25 is 5, and that leaves us square root of 5. And that would be our distance. And that is using the distance formula.